Hello, everyone, and welcome to this webinar from OptiWave on a newly product introduced to the market, OptiInstrument software. And we're going to describe today the new product and make a demonstration on live, not live demonstrations, demonstration recorded actually. And then after that, we're going to open to the questions and answers. So welcome everyone to this webinar. There is few handouts you can download them from this webinar, and also you can download the videos as well. So to start with, this webinar is prepared by my colleague Jaydeep Brahmbhatt and myself, and Jaydeep is prepared the demonstration part of it, and I'm gonna give the details about the product. So to start with, we're gonna talk about some history about OptiWave. OptiWave is established in 1994, and it's located in Ottawa, Ontario, Canada. And OptiWave offers different software products which can be used for designing and simulating, as well optimization the designs of components, links, systems, and networks. And this software can give advantages to the users to shorten their product time introduction, to improve their product quality through these simulations ahead of time of making the product, as well as enhancing the productivity and cost effectiveness. OptiWave product is basically licensed to over than 1,000 industry leaders in the market, as well as universities, research institutions, and governmental institutions in over than 75 countries worldwide. Some examples of these companies and institutions depends on their product lines of in photonics component and module suppliers. There is companies like Viavi, Olumentum, which used to be JDS Uniphase, Corning, Oclaro, 3M, Intel, Oki. In the telecommunication market equipment provider, there's like Nokia, Huawei, IPG Photonics, and EC, Sienna. And in telecommunication service provider, we have customers like NTT, AT&T, Bell Canada. In the national defense contractors, like there is many of those, and then companies like Lockheed Martin, Raytheon, Boeing Base Systems, Thales. Non-profit organization, there is Sandia National Laboratories, National Research Council, Battelle, and Communication Research Centers. Universities, many as well of those, some of examples here: Harvard, MIT, Stanford, Ottawa University, Toronto, McGill, Tokyo University, Shanghai University, and so on. OptiWave products can be categorized in different categories. One of them is related to system level. So we offer two products here. We offer Optisystem and we offer OptiSpice. These products can be used for designing system levels and component levels in optoelectronics region as well. And component level software, we offer OptiBBM, OptiFDDT, and OptiFiber, as well as OptiGrating. And these are the legacy products of OptiWave. And the newly developed and introduced to the market product, which is today's webinar about, is OptiInstrument. And it's mainly used for communication and control of instruments and equipment. OptiInstruments, you can download it, and as well as all other software from OptiWave website. So once you go to the website of OptiWave and you go to downloads, then you go to click on 30 days evaluation. You're going to have the pop-up window here where you register. Once you register, you can download the free trials, 30 days free trials of the software. And once the software is downloaded, the files of the, let's say, for example, we are talking about OptiInstrument today, the files will be saved under the program files, OptiWave software, OptiInstrument 1. This is the version of OptiInstrument introduced to the market today. Now the files which you're gonna see in that directory under OptiInstrument in the program file directory, you're gonna see the bin and documentation. And in the bin directory, you're gonna see the executable file of OptiInstrument as well as some libraries here. And in the other documentation folder, you're gonna see the 3 main documents here, which is the getting started document as well as the new features document and release notes. OptiInstrument GUI, this is the GUI, how it look like. We're going to talk about this in details and every part of this GUI. Mainly OptiInstrument here, as you can see, the title of page of the GUI here, it shows you the file name here. The first default file you load, you're going to have OptiWave here, and then once you save the file and you load it, you're going to see the name of the file appear here, and then the OptiInstrument. Then the GUI has many, as you see here, pins, and these pins, some of them are dockable, and you can use them, and we're going to explain every part on every key here in the demo today. Some features of OptiInstrument software. First one is it is a user-friendly GUI, and this is one of the major advantages of OptiInstrument. It's easy to use, as you're gonna see. Everything is defined, and you can just click on it, and then you can achieve what you need from that feature. OptiInstrument allows the users to execute a single Skippy command. So the software is based on communicating with instruments based on Skippy commands. So the communication protocol is using Skippy commands, and you connect to the instrument physically through a USB cable or a serial cable, as well as you can connect remotely through Telnet and TCP/IP. Now in the GUI, you can we allow you to execute single command by command or sequence of commands, as we're gonna see in the demo. Now you can load XML files which have the Skippy commands to the software, the GUI, and in there you can do drag and drop commands into a dedicated window there, where you can organize these commands in sequence, and you can execute the whole commands or a partial set of commands in the window. You can generate Python script for a single command, or you can generate a Python script for the whole sequence of commands, and then you can run again is the Python script from OptiInstrument GUI, or you can run it from externally through the command prompt or the shell, Windows shell. It has the GUI has a built-in viewer, and in the built-in viewer you have a signal viewer where you can look at the images of waveforms and traces of the equipment you are viewing, as well as you can look at the data of these files and download these files as a CSV files and process them later on. OptiInstrument GUI has a Python script editor, fully capable of doing all the features of a Python script. And then again, as we construct here about, we can do the control of the communication of the instrument remotely. Now the GUI, as we said, it has a dockable windows, which you can take them out and you can control the sizes of each window in principle, as we're going to show you in the demo. Applications of OptiInstrument, you can again remotely or physically communicate and control the equipment. You can set up parameters of these equipment, so you can have equipment, and then the parameters of the equipment can be varied. Set, let's say, for example, wavelength. You can set for a laser. You can set frequency. Set whatever the available parameters in the equipment supported by the Skippy commands. You could be able to access them and control them and set them up. The process, the GUI can allow you to automate the testing and characterization. This is very good advantage for test floors, for manufacturing at test floors, you can do the skippy commands for this setup of equipments, and then you can run it and automate the testing. We can show you some examples today about this. And you can do some long-term stability. So you can run like for example, if you, let's say, wanted to test certain parameters, you can run it for a long time, and you can control the process of the test. You can display generated signal, as we mentioned, in one of these windows in the GUI, and you can extract these waveforms, and you can save them as an image, or you can save them as a data file in a CSV format. You can integrate these instruments with other photonic and system simulation tools, so to get, for example, real data into your simulation tools. In terms of OptiInstrument display and data acquisition, the waveform is produced by the instruments, and you communicate with this instrument, and you capture these waveforms, can be displayed on the display window, as we mentioned. So this is an example showing, let's say, here a function generator and oscilloscope, and this is the GUI connected here. And you can see, and this is the display window, and shows you the waveform. This waveform can, again, saved as an image, or can saved as data file, as a CSV file. The capture waveform can be processed, as I mentioned, and displayed. The data can be saved as CSV file. Now we're gonna just show you here in this slide the just general look of the GUI, how it look like with the skippy commands. And this is the window for command sequence. You arrange the command sequence which you wanted to execute in this window, and then once it's run, give you the status here, and then you can save and do multi functions on this this GUI. All of that we're going to be showing it in the demo today. The saving project, instruments project. So OptiInstrument have the capability. You can use the file save in here, so you can save, for example, if you have in the GUI, we allow you to load documents. So here you can have a document tab. Once you press on it, you have a window here where you can load any type of files into the GUI, and then you can save the file with the skippy commands into a directory, and then later on you can load the file. Once you load the file, you have the name here, .oid. This is the format we save the files in, and then you can load it and can run the file again without any need to recreate the skippy commands and looking for the process to execute. And this is very a good advantage in the manufacturing floor, where you have all these skippy commands saved in a file. In case, for example, something happened, you just load the file and just run the file again, and that's it. Python scripting, as I mentioned, the GUI allow you to generate a single Python script for single skippy command or list of skippy commands, and then you can execute these commands from externally or from the GUI itself using externally using a command prompt or Windows PowerShell, and internally you can use the GUI itself, the dedicated window for the Python editor. And you can load, as I mentioned, load a Python script into, you can edit the Python script, you can load Python script and edit it and then execute it as well. So all of that is capable, it is possible. This is the window used for the Python editor, and then you can again do all the processing and calculation and execution in this window as well. Now, OptiInstrument, once you download the software, you would have an example library, and this example library today we have implemented different examples for Expo equipment, the LTP8 platform. So there is different cards in this platform. We use them, lasers, switch, optical spectrum analyzer, attenuators. We use as well the power blazer to test transceivers. So all of that examples are listed in here, and also you can access them into from the example library in OptiInstrument example library. Also, we did examples for Regal where we have different waveform generators, and we demonstrated like that. So once what you do there, once you go to the directory and you can access that file, you have the XML files. You just only load them, and you should be able to test the file. We have different, as I said here, examples doing looping, doing data parsing, you're doing stability testing, and so on. So it's lots of examples at this moment. And I'm going to take this opportunity to say we are looking into collaboration with the different manufacturer of equipment to add their equipment into OptiInstrument. So this is something which we are open to do and collaborate with vendors to add their equipment to our software, which give an advantage for the user to take these examples and then run the equipment right away with these automated files to operate the equipment. Now, the demo today is going to take different parts of it. The first part would be describing the OptiInstrument GUI. So we're going to go in details on the GUI and show you how every key or window it works, how it works. And then we're going to demonstrate the communication and control of X4 equipment, the LTP8, which has 4 CW lasers in it, and plus a switch where we take one laser at a time, and then we attenuate, and then we pass it to an optical spectrum analyzer to measure its power and its wavelength. And then we save these results, and then we parse these results and arrange them. So we have a Python script to do the data parsing and processing. And next step, we do also the BERT testing for the transceiver CFB4 100G Ethernet in a Power Blazer card in X4 platform LTP8. And then we do also Python scripting there to do data parsing and processing for that. And then at the end, we do the Regal equipment demonstration to show you how to do the function generator to generate a waveform and then display it on the oscilloscope, then use it in the viewer of OptiInstrument. At the end, before I start the demo, here is just only a link for Optical Society of America. They have a technology showcase planned between 18th and 20th of August. OptiWave is participating part of it. This is the link to register, and we are presenting on the 20th of August about OptiInstrument, and then we open for discussion room for 1 hour. So anyone interested, he can register, and then we can have one-on-one discussion and demonstration and whatever needed to do. Okay, so before we go to this part here, I'm gonna go to the videos, and I'm gonna start the first video here to show you the demonstration.
So in this video, I'll be going over OptiInstrument features and functionality, and a little bit later, I'll be demoing how to execute sequences and showing some of the other capability of OptiInstrument. So first off, we have the standard toolbar at the top: File, Edit, View, and Help. File and Edit are pretty standard with the standard options. Then View, you have options for hiding and showing different toolbars and docking windows. And then you have a Help drop-down menu. In order to get to OptiInstrument user manual, you have to go to Help and then go to Getting Started Guide. This will open the user manual, and other relevant information about OptiInstrument is also in the same drop-down menu. Then we have some buttons here at the bottom. We have the refresh button, which will connect to instruments automatically when they're available over the network that you're on, or if they're physically connected to the instrument. via the workstation. Then we have the display waveform button. This is used for acquiring waveform data and data points. Then we have show and hide buttons for the command sequence window and display panel. And we also have a help button. This will take you to the about section of OptiInstrument, where there's information regarding the product version and other relevant information. Then we have a bunch of tabs here on the left. Um, Other than that, we have a single skippy execution window here, where you can type in a single command and execute it. Then we have a command sequence window here, where your command sequences will show up, where you can also build your command sequences, modify them, edit them, and then export it as well. Then we have the display window here, where you have two tabs. One is graph, where your waveforms will appear, and the other one where your data points for the waveform will appear. So going back to the tabs on the left, the instruments tab is where you connect to your instruments, and where it will be listed, and you have options like alias setup in the instruments tab. So to set up alias, you can simply just go to the alias setup and then modify the name in the alias name column, and then press OK. But before you press OK, make sure you check off the in registry, so you won't need to do this setup for future. And in the instruments tab, we also have options for entering IP address manually, and then port number, and then you can connect it to the instruments manually as well. Then moving on to list of command sequence. Here you can import and export your command sequences that you're working with. For example, here I'll just import a sequence I'll be demonstrating today. You can expand the list here as well. Then going to Skippy Commands tab. This tab has, as a default, all the common commands that are supported across all instruments. But you can also import other libraries and other Skippy manuals and references that you're working with. So you can import it, and then once imported, you can expand the command tree until it shows you the entire command. And once you see the entire command, you can drag and drop it in either a single Skippy command window or your command sequence to start building your sequences. So this tab is very useful. You can have multiple different XML files or Skippy command trees that you can import in here, and then you can work with your instruments that way. Then we have a documents tab. Here you can import your PDF documents like user guides and other references that you can import here, and once they're imported, you can double click on them and they will open up in Adobe Reader. And so this is a good way of having all your reference material in one space where you can refer to them quickly. Then we have this Python script tab. This is where the Python script will show up when we generate a Python script, either with a single command or a command sequence. They both have a Python script generator button. So I'll show how that is done in a little bit. Um, then moving on to the single Skippy command tab. Here we have on the top we have buttons to add to the sequence, clearing all the commands from the text box. We have a button for identification query, which you can send, and as you saw, the response from the instrument is shown in the response box, and any errors or any exceptions that are thrown is shown in the error box here. Um, Also, you have the Python generator button here on top, which I mentioned earlier, and then you'll have a drop-down menu for selecting the instrument that you want to send the commands to. Other than the single command execution, there's another tab at the bottom here, which is the settings tab. This will have all your TCP/IP settings if it's a TCP/IP instrument that you're connected to, and you will have parameters like timeout, termination character, and read and write buffer size. And obviously this will change depending on type of instrument you're using. So for example, if it's a serial instrument, you'll have completely different settings. So that's the single Skippy execution window. Then we have the command sequence window. This is where you have your sequences, and you can construct them, you can modify them, you can export them. So as I showed earlier, you can add single commands to your sequence to start building a sequence, or you can have a ready-made sequence which you can import and start editing if you needed to. And for that purpose, we have some editing buttons here at the top. There are some for moving commands up and down, then some are for clearing your rows and your empty lines. Then you have a copy paste, undo, redo, and Python script generator button as well as export results button, where you can export your results in a CSV file format. On the left here, you have four main buttons for your sequence execution. You have the first button is for running the entire sequence. The second one is for running selected commands that you want to run individually. Then you have a pause button, you have a stop button, and on the right here you have an option for naming your sequence, and the last option you have is sleep time, which you can enter, and the sleep time is for whatever time you want in between commands, because some instruments will take longer to execute a certain command, so you want to put that sleep time in so that uh, your sequence is successful. And then lastly, we have the display window here, and it has two different tabs. One is the graphs tab, where you will have your waveform and graphs, which will show up when you acquire the data from oscilloscope or OSA. And you have the grid tab, where you will have your data points in a Excel format. So for waveform images or or any graphs that you want to save, you can do that by clicking this button on the top left corner, where you will have options for customizing your graph or how you want to visualize it in this tab. Then you have options for saving the image of the graph or waveform in different file formats. You can also export your data, uh, and you can change other properties of the graph. And in terms of the data points, you can also save that with export button here. So moving on to our first sequence here. Um, as I mentioned earlier, I'll be uh, demoing a sequence, and this includes exfo equipment, It has 4 different instruments that are included in this uh, sequence. So first, just to go over the setup. So what we have here is 4 CW lasers, which are going into optical switch, and from there they're uh, going into an attenuator where an attenuation is applied, and once attenuation is applied, it goes to optical spectrum analyzer where the um, signal is detected and some of the measurements are made. So what we have is 4 different lasers, but it is happening in sequence. So you have the first laser going into the optical switch, then some attenuation is applied, and the signal is analyzed by the spectrum analyzer of the first laser. Once that's done, it moves on to the second laser, and so on. So that's how the sequence is set up. And to execute the sequence, once I've imported it, I just need to drag and drop it into the command sequence window. Once I've imported it, and I'll just open it here in a free floating command sequence window so I can see the entire sequence. And this sequence won't require any sleep time between commands because it's relatively simple sequence, and the commands that are being sent are not going to take long for the instruments to set up. So I'll go ahead and enter 0 seconds and start the sequence. As you will see, when the sequence is started, it starts executing, and while the sequence is running, you will have a progress at the bottom here where it will show you the progress of the sequence. So it's the first laser that it's being detected by the optical spectrum analyzer right now, and it has collected these measurements for that laser. Then that laser is turned off, the second laser turns on, it is going through the optical switch, then attenuator where a 10 dB attenuation is applied, and then to the optical spectrum analyzer where it will do measurements like central wavelength, central frequency, and peak power, and then turning the second laser off, going on to the third laser, going through the optical switch, applying 15 dB of attenuation, and then optical spectrum analyzer will make its measurements. Again, these measurements are repeated for this sequence's sake, so you can see the data points being collected. And once this sequence is done, which is almost done, will be going over how to save this data and then process it uh, so that you only take away the relevant information from the data file rather than reading off the entire file. So it has done executing. It was successful, no errors. And so now let me go ahead and save the results. I'll go ahead and export the results. So I've exported the results, but just to show the Python script capability within the OptiInstrument, as I mentioned earlier, you can create a Python script for the entire sequence. You can click the Python generator button, and as you can see, you have the entire script, which will show up in the Python script tab on the left. And here you can edit it and make your modifications, and then run it outside of the OptiInstrument application. So moving on to the post-processing data. So we had our data file that we saved here. As you can see, this is the current data file, where it shows you the instrument name, your commands, your type of commands, and your data points. Now we will process this data with Python script, with only having relevant data. So let me go ahead and execute the script. I've executed the script. It's done parsing the data that I needed. And when I go back to the results file, you will see that we have our relevant data for the sequence that we just ran. We have 4 different tables, each with different wavelength, with attenuation, which was applied to each laser, and what were its power levels when measured. So yeah, this is a capability that we will be adding in the next release of OptiInstrument, and we're hoping that this will become one of the main features of OptiInstrument in the future. And so I just wanted to show you what will be coming to OptiInstrument in the future, which will be the post-processing that the user can do without requiring any programming knowledge. And then we'll move on to the next part of the demo. So in this part of the demo, I'll be showing you how to work with Regal equipment, and how to capture data from an oscilloscope and other measurement and testing equipment. So first I'll go ahead and connect to Regal equipment by typing in the IP address. So I've connected to the oscilloscope, and now I'm going to connect to the function generator. So I've connected to both the instruments, and now I'm going to go ahead and import the sequence that I have already prepared for this presentation. Um, and so in this sequence, what we have is a example of harmonic waveform generator. And once I import it, I have it here. I'll just drag and drop it into the command sequence window. So what we have here is a function generator that's doing parameter setup, where it's setting up amplitude, phase, and those kinds of settings, and then those are sent to oscilloscope to generate the harmonic waveform. So for this sequence, we don't require any sleep time, so I'm just going to go ahead, enter 0, and go ahead and execute the sequence. So as you can see, it's really quick, and when it's executed, I can display the waveform from the oscilloscope by going to the available instruments drop down menu on the top of Skippy command execution window. And once I've selected the correct instrument, I just go over to the display waveform button on the top left and click that button. This will initiate the script, which will display the raw data. As you can see here, these are the raw data points for the waveform, and we have the waveform here. So as you can see, you can capture your raw data points as well as your waveform. And as previously mentioned, you can save this image with a BMP file, or you can change save it as any other image file format. And as for the data points, you can save them as a CSV file. So that was the demonstration showing how to work with Regal function generator and oscilloscope, and how to capture data with OptiInstrument. Okay, so last part of the demo here. In this part of the demo, I'll be working with Expo instruments again. So just to explain the setup here, we have the FTB X88200 NGE Power Blazer card with a CFP4 transceiver inserted into it, and CFP4 has a loopback fiber that's plugged into it for this Etherberg test, which is Ethernet error bits rate test. And so this is the general setup, and this sequence will be executed using Python. Um, this Python script is using these Skippy commands, which are setting up various parameters for the Etherberg tests, like lane, your framing, a bit pattern type, the size of the frame, and then I'll be injecting 25 error bits manually. And once they're injected during the test, which will be about 4 to 5 minutes, we will be counting uh, or rather querying the count for the total bit rate, and what are the rate of mismatch for mismatch zeros and ones, and then the actual error rate itself over the course of the, the sequence. And so that's roughly uh, the sequence that we'll be executing today. So let me go ahead and run the sequence. So here I have the Python script, and I'm only running it once. This Python script was also made to showcase the capability of OptiInstrument in the future, where you will have the capability to execute Python script within the OptiInstrument application. And so by showing uh, this sequence through Python, and showing the data processing once the sequence is done, these are some of the features that would be added into OptiInstrument in the future. So let me just go ahead and start the sequence. So as you can see, it has started. Um, so I'm just gonna fast forward this because this sequence will take about 10 minutes to finish all the commands, and so I'll just go ahead and fast forward to when it's done so I can show you the data processing. So it looks like the sequence is finished executing. As you can see, it did one iteration of the sequence and it took about 10 minutes. And so once the execution was done, it created a log file, which you can see here. And when you open the log file, it will look something like this, where it has a lot of information, but we don't need all of this information. So we'll be going ahead and parsing the data and getting only the relevant information that we need. So in order to do that, just like the other sequence we did and did data parsing, I have another script here for data parsing as well, and I'm gonna go ahead and execute this data parser here. So remember, as I mentioned earlier, this is one of the features that we want to include in the next iteration of OptiInstrument. So this post-processing of data will not be needed for a user to do it in Python. This will be included in the OptiInstrument application. And once, as you saw, I finished parsing the data and created this Excel file with just the information that I needed, which is the total bit error rate, and in that what are the mismatch zeros and what are the mismatch ones. So yeah, this was the demo of OptiInstrument, its capability and features, and what kind of features we'll be looking at in the future.
Okay, so thank you very much for listening to the recording demo. I just wanted to comment on a few things. Is the parsing part at this moment is done through the Python script externally. However, as my colleague JD was saying, there would be an addition to the GUI where this is going to be done in a way that users will enter it in a kind of block inside the GUI. So you're just only dragging the parameter which you need to parse. And the other part of it is the saving part. It has been already implemented in OptiInstrument. So the next download, if you do it after August, mid of August, you're gonna have the latest version which has this implementation. For the time being, right now, we are open for any questions. So if you have any question, please send it to us, and then we'll try to answer it. And JD is standby right now on the equipment. So if you need any question from him, also he can demo or can show it to you live. So I have a question actually here, which says about the how to import the skippy commands. So the issue about skippy commands is this way. Typically, equipment when you buy it, you have a manual, and in the manual you have the skippy commands. So the skippy commands, as a user of the software, if the instrument is part of the software, then the skippy commands for certain application is already done for you, and there is a file saved in the example library showing these skippy commands. However, if it is a new equipment, like for example, the user needs to write or get the skippy commands from the manual, and then put them into the sequence and then save the sequence, and then later on he can use them at any time. So he can save the sequence of command as an XML file, and then he can load the XML file at any time. Another question is here about, does it has any compatibility with Optisystem and OptiBPM? So at this moment is the data file, we are writing the API to integrate OptiInstrument with Optisystem. So this is something which we are targeting by end of September to have the API. So at that time you should be able to communicate with the equipment, get the data from that equipment, and then use it in Optisystem. So that's one of the vision we are looking into it for this software, is to integrate OptiInstrument not only with Optisystem, with all OptiWave software eventually. Another question here we have, can we import all components of Optisystem? I'm not sure about what it means here, but import all components in Optisystem. Like, I mean, the components in Optisystem, let's say you have oscilloscope as visualizers, you have components like fibers, switches, you have attenuators. So any equipment which is like, I mean, physically you have an equivalent to it, you should be able to import the data from that equipment. So first of all, you need to communicate with that equipment, set up that equipment, and then import the data of that equipment into the Optisystem, and then use it in Optisystem. And that's the API, the application programming interface is working. We are working on it to do that. Another question, can we say here, will the Optisystem be available for university community via CMC? Like, I mean, typically CMC acquire the software from us, and then they make it available to them. For us, is we need to arrange that with CMC, or CMC arranged with us to do that. Now, the software itself, you can try it at this moment at first for the 30 days trial, and then you can acquire it. It's not that expensive. You can send us an email, and we can send you the
notation.
Okay. Another question here. I'm just trying to follow up. Is the software compatible with Cisco, Juniper switch and routers? Okay, thank you. So as I mentioned at this moment, in one of the slides which we put here, we are hoping to collaborate with any vendor because unless we, like, the issue is once we know the SCIBI commands of the equipment, it's easy. It's just only we can have it as a file in an example library, and then the user can, any user can use it at this time. So we can release it, and then the users can use it. So we are open to collaborate with any vendor, with any manufacturer who are working with automation, and we can collaborate with them to make their XML files part of the example library of OptiInstrument. Can it be used with NetSim? Will be send this recorded video. Okay, so the recorded videos are of the webinar itself. We're gonna make it available later on, but at this moment you can download the from the handouts the videos which is done, the demo, and also the webinar itself slides as a PDF files, and the release notes. Now the release notes, you can download them from the download of the GUI. Once you do the 30 days free trials, you can download all the related documents. One of them is the release notes and the user manual to operate the software. Another question here we have is, can be downloadable in future. Anyway, we're gonna load the webinar on OptiWave's website, and then make it available to user in the future, definitely. Okay, any other question? I think with this, I would like to thank everyone for attending the webinar. We're gonna send the recording of the webinar, a link for it later on. and make the slides as well available. Thank you very much for attending today, and we hope to see you in the future. Thank you.